Welcome, guys. Sorry I could not make it again today, but I have a sick little kiddo at home, so I'm hanging out with him. But we're going to go through these hexadecimal and two binary notes that we have. And this is mostly because, as I mentioned earlier, that hexadecimal and binary have a really cool connection together. So on this right-hand side, I've given you a list of all of the hexadecimal values, 0 through 15, and their equivalent binary values. Take note that in these binary values, these are what we call padded values. And the reason that we call them padded is because we don't usually write the number 0 with 4 zeros. It's usually just a single digit. So we pad it so that it is 4 characters long. And so that's the idea of padding. We usually pad things to like 8 characters as well. Just depends on the scenario we go to. But what we're going to do is use this list here to kind of relate how hexadecimal and binary are related to each other. Take a look at this number that we have up top here. This 60D is a hexadecimal value. And what we do is we can look at it individually as characters and actually take the hexadecimal digit that we see and just replace it with the four-digit padded binary equivalent. So for example, the very first hexadecimal character we see is a 6. And if you come down to your chart, here's the 6 for hexadecimal. That is the equivalent of 0110. Well, that we can just replace with what was the character for the 6. So these 4 red 0s and 1s represent the 6. We repeat this for every hexadecimal character that we have. A 0, conveniently for everybody, is just zeros. And then the letter D, if we look it up, now I always think of the equivalent of D. If A is 10, B is 11, C is 12, D is actually the number 13. But on our list, 13 is going to be represented as 1101. We add that together. Congratulations. If you wanted to represent 60D, a hexadecimal number, as a binary number, it would be the combination of those 12 zeros and 1s. And this also works in the opposite direction. This one's a little less fun because you do have to match up your binary digits, which can sometimes be difficult. But if I look at this character right here and play the Where's Waldo, that does look like down here that should be a 5 in hex. And then if we look at this character right here, that does look like the letter E in hex. So I would assume that this would be a 5 and then an E. Wow, we're getting good at this stuff. So this was the cool relationship that we see here. Oftentimes on an AP exam, they might say something like, can you convert this hexadecimal number to a binary number? These are some very convenient ways of doing this. Of course, you will always be able to do it's called a double conversion, where if you have a hexadecimal number, you can convert it to a decimal number or a base 10 number. And from there, just convert it again to the base that you need to. Problem is, right now, we don't know how to convert from base 10. That is actually going to start on our notes tomorrow. But for us today, the last thing I wanted to point out for you was your programs and how I can give you a good hint in the right direction for how to make your hexadecimal to decimal function work. So let's take a look at that one really quickly. Here is what I have for my code. You guys probably have something extremely similar. I'm really going to focus on this binary to decimal function that we have right here. And the reason I say that is because, like with the octal to decimal functionality, we really can steal a lot of this. And this copy paste is so fun and useful for us. We will go through and make sure we change some of our variables. So for mine, I will have a decimal answer still, so we are converting this to decimal. This is no longer a binary array. This is a hex array. So basically every word that I see as binary, I'm going to come through here and change that to be the word hex. Because again, they are giving us a hexadecimal number up here. We are then converting it into a decimal number. We're almost finished, I think. There we go. Otherwise, this is exactly the same. The last time we did this with octal, the only other thing we did also change was we changed this 2 to be the number 16, or I'm sorry, for base 8, it was an 8. Since we are in base 16, we'll change it to base 16. But we do run into a problem. The problem is actually going to occur on this line right here. Because in base 2 and base 8 numbers, when we grab one of the digits, we are guaranteed in binary that it's a 0 or a 1, and in octal, we're guaranteed it's a 0 to a 7. Well, we can take those and convert them directly into numbers. That's fine. The problem lies now with hexadecimal. When I go to my hexadecimal number and I grab one of the characters from it, it could be the numbers 0 through 9, which I can convert to numbers, or it could be the letters A through F, which technically we would have to do the conversion ourselves to those numbers. So how we're going to solve this is we're going to say, you know what? Before I actually convert that character to its number or numerical equivalent, let me just grab that one character from the hex array and call it my digit. And before I convert it, I need to make sure to test it against any of the letters that could cause problems. So for example, I can come down here and say, well, what if my digit that I just grabbed a hold of from my array was actually the letter A? And sometimes I do like to add this in here. We can use an OR statement because technically we could test for a lowercase a as well. So I might say, well, if my digit is an uppercase A or it is a lowercase a, then I know something about that digit. If I wanted to convert it to its numerical value, that is actually going to line up with the number 10 now. Anytime I see an A, I want to think of that equivalent as 10. And what you guys are going to do is you are going to continue on down this pathway where you test some other situation very similar, but probably for the letter B, and you give your digit some value at the end of the day that you know the letter B is worth. You are going to continue this, continue this, continue this, continue this, all the way down until your last else statement. Because you're going to have an if-else statement. So all of these will be contained for A, B, C, D, E, and F, 10 through 15. But logically, you also want to think of this is if you make it through all of these, and you know for a fact it is not a letter A, B, C, D, E, or F, you can guarantee it's a digit between 0 and 9. So what we can do is we can just say, well, take the digit and give me the number version of itself. I just tested and made sure that it was not the letters A through F, because if it was, I assigned it its a correct value. But the catch-all at the bottom, if you passed all those tests above, I can logically guarantee that you are a number, and I can take you and convert you right away to your equivalent of your number. Now that this variable digit has its correct value, even if it's a letter A, I know what its correct value is. We can now utilize that in our whole entire program to calculate out the base 16 value for that placeholder. That is where you guys are going to have to do a tiny bit more work, get some of these else if statements in here. Again, you should have one for B, C, D, E, and F. Your last else statement catches all the other digits. Don't forget to return your decimal answer at the very end. And the final step that you will have to do is just adding another functionality to your convert that we have. This process is still the same. We're gathering all the input from our user, the number that they wanted to convert, what drop-down menu item they selected. We have tested, hey, what if you're doing base 2 to base 10? Well, otherwise, what if you're doing base 8 to base 10? Well, I think you probably know what's coming next. We have another else if statement of some sort that says, if you've got this thing, I want this to be the sequence of events that actually happens. The very last thing is, once again, get that value displayed into the text box. So this is hopefully going to give you guys a little bit of time to get through the functionality of the base 16 to base 10. Quick reminder for you guys, two things. One, If you have not yet completed MC 14 on AP Classroom, please go through and do that today. If you want to do that in class, you're welcome to. MC number 15 is technically assigned to you today, but it will not be due until Thursday. Be careful, that one is not on AP Classroom. It is actually on Schoology. So check out that one. I'll make sure to put the due date on there so it pops up on the right-hand side column for you under your assignments. And then the other thing that is probably one of the more important things to look forward to, you guys need to make sure you are registered for your AP exams, not just through AP College Board, but through the total registration website that is offered via Fremd. And this is again where we are on AP Classroom, we are saving a spot for you, or they're going to kind of fulfill the requirement on their end. But in order for you to actually take the test, you do have to pay Fremd to do that. So I believe today is one of the last days, if not tomorrow. They might give you tomorrow. Might as well get it done today, though, just to make sure. And then I will go through and make sure that I call off all the names of people who I have when I return on Wednesday for you guys. Wanted to keep this video nice and short. Good luck with the rest of your programs, ladies and gentlemen. Hopefully you did the warm-up earlier. I appreciate you guys working through that. Please help your neighbors if they have any questions on understanding either the code or the warm-ups themselves. And then we'll go over all these tomorrow. Take care, ladies and gentlemen. We'll see you on Wednesday. Happy Halloween!